Okay, hey guys. So we're finishing off chapter 14 in today's notes. So specifically today we'll be talking about amines and amides. So that's sections 5 and 6 in the textbook. And there's lots of practice problems for you guys to practice and try. So this first section we're talking about is amines. An amine is a functional group that contains a nitrogen, and where everything around it is either a carbon or a hydrogen. So the one caveat to this is that if there's a carbonyl next to the nitrogen, then it's an amide, which we'll talk about in section 6. So this could be, in our next slide, you'll see a little bit more details about this, but you could have a nitrogen with 3 hydrogens around it. That's called ammonia. Or you can have carbons on it on any of the different parts of it. So you can have 1 carbon, 2 carbons, 3 carbons, whichever one around that nitrogen. So some characteristics and uses. One of the big ones is that it's used as a base in a reaction. So those lone pairs on those nitrogens really like to interact with hydrogens, and so it'll steal hydrogens away from other things, acids such as carboxylic acid, like we talked about in section 1, I believe, 2. And then additionally, amines are super duper common in pharmaceutical molecules. So we'll have some examples in later slides where we talk about some pharmaceuticals and the amines that are in those molecules. Solubility is pretty similar to alcohols. So it has hydrogen bonding interactions, and those hydrogen bonding interactions are going to be different based off of how many substituents are off of that nitrogen. So this particular hydrogen bonding model that I'm showing you here is just specifically for this kind of amine. If you have more hydrogens on that nitrogen, then there's going to be different or more hydrogen bonding interactions there. And then so solubility, our little chart that we have here, numbers of carbons. So a amine is generally soluble if there's between 1 to 4 carbons. It is slightly soluble if there's between 5 to 6, and insoluble if there's greater than or equal to 7 carbons. So this is very general. There's other factors that will go into this as well, determining that solubility. And then additionally, we're going to look at the classification of amines. So we talked about the classification of alcohols in chapter, I don't remember, 12. And that was based off of the number of groups on the carbon the oxygen was attached to. Whereas in the classification of amines, it's kind of completely different, which is a little bizarre, but it's the number of alkyl groups actually attached to the nitrogen atom itself. So for example, if we have a primary amine, it's going to be where we have, let's do colors. We're going to have 1 R group, which stands for something that's carbon-based, and then we'll have 2 hydrogens on it. So we have 1 carbon group on it, therefore it's a primary amine. So some examples of this are going to be things like you can just have NH2 with a methyl group on it, or ethyl NH2. But something to point out is how many carbons are attached to that carbon doesn't matter like it does with alcohols. So for example, I could have this. This is still a primary amine. And if that were an oxygen, it would be a secondary alcohol. But this is still a primary amine because now we're talking about how many things are connected to the nitrogen itself. And then in continuation, we could also have something like this. This is still a primary amine. Secondary amines are now going to have 2 things connected to the nitrogen atom itself. So we have 2 R groups and then 1 hydrogen on there. So we'll number them 1, 2, well, maybe we'll circle these. So we have 2 groups attached to nitrogen, therefore 2, it is a secondary amine. So examples of this, we could just have dimethylamine, we could have ethyl groups on there. We could have even isopropyl groups, or tert-butyl, that's what that's called, but we can have anything like that on there as well. And they don't have to be the same on either side, they can be different. So tertiary amines, if you're following our pattern here, is going to have 3 R groups or carbon groups on the nitrogen. 1, 2, 3. So examples of this are the most simple example would just be 3 methyl groups, but you could also have 3 ethyl groups. You could have something more interesting, like you could have a phenyl group, and then something like that, whatever you want on there, as long as the number of carbons on the connected to the nitrogen itself is 3. So doing a little bit of practice in comparison to other functional groups that we have learned. So this is asking us to identify the functional group of the following molecules, then classify them as primary, secondary, or tertiary if applicable. So this first molecule here, I have the nitrogen, so I'm going to have an amine, and I have 1 carbon atom attached to that nitrogen, so it's going to be a primary amine. Let's go down though and look at the same exact molecule, but now with oxygen. Now we have an alcohol, but with alcohols, we look at to see how many things are connected to that carbon. So I'm going to look at this carbon now and see how many things are attached. And we have 1, 2 attached things. So now we're going to have a secondary alcohol. So you see how those are different? We're looking at 2 different places for these. Continuing on, we have another amine here. And then let's see how many things are connected. We have 1, 2 carbons connected to the nitrogen. So we have a secondary amine. And then looking down at this bottom one, now we have an ether, which we can't classify. Those always have 2 carbon groups on either side. So as you can see, alcohols are very different in terms of classifying than amines. So make sure you have those rules separated, because as you change the number of things attached to oxygen, you actually change the functional group. Whereas for amines, it's just a different classification of the same functional group. That's where we're going to stop on this particular video, and we'll pick up with naming some amines. There we go.